Good morning, children. In this video, we will be discussing arrange the following questions on the basis of the different properties indicated based on periodic classification and its different periodic properties. So the first question is, these species are given I plus, I minus and I. These are all of iodine, same atom. Electron is lost, electron is added on the basis of the size if we are asked to arrange. In this it's very simple. We know cation is smaller in size because cation is formed by loss of electron and anion is formed by gain of electron. So the order will be cation is the smallest, then you will have a neutral atom and the maximum would be I minus. That is anion. Anion is largest in size. Cation is smallest and put the neutral atom in the center. Now, these are all isoelectronic species. These are isoelectronic species. All are having same number of electrons. 10 electrons are there. Right? So, in this, you will have to check for the charges. More the positive charge, smaller the size. More the negative charge, larger the size. So you will be arranging them increasing order. I am arranging. If you are asked to arrange them in the increasing order, see to it the smallest is first and the largest is later. In case you are asked to arrange them in the decreasing order, then it will be reverse. Please do not write in the different order. If increasing is asked, if you write decreasing order, then you will be marked wrong. So in this it is increasing order. In all the questions I am arranging in the increasing order. Al3 plus the smallest. Then you will have Mg2 plus, then after that you will be placing Na plus, thereafter neon, neutral atom, then F minus, then you will have O2 minus and the largest would be N3 minus. More the negative charge, larger is the size. Same is another set of isoelectronic species taken. These were all having 10 electron and these are having 18. So the smallest would be Ca2 plus, then you will have K plus, all are having 18 electrons, then you will have argon, this is Ar, argon, after argon you will have Cl minus, 1 negative charge, then you will have 2 negative charges and then finally 3 negative charges, the largest in size. Right? Now, ionization energy. When you are given some examples to arrange them in the increasing or decreasing order of the ion, some property, check whether they are in the same group or period. This example, they are all in the same group. And we know down the group, ionization enthalpy decreases. So that means the one which is on the top will be having the maximum ionization. So they are asking increasing order. Increasing order is cesium is the least. After cesium would be rubidium. After rubidium is potassium. After potassium is sodium. So increasing order. This is the smallest. Sodium is smallest. So this will have the maximum ionization enthalpy. This is when we are talking about group 1. I mean this particular example, all the elements are from group 1. Right? The next one. It is, some set they have given. N, P, O, S. First let us see, are they in the same group or in the same period? Let us see. They are not in the same group or period. So it's like that. B, C, N. N is here. Then you have O. I'm just writing the positions, how they will be placed. Below nitrogen is you have phosphorus and after this you will have sulfur. This is how they are placed. One section of the periodic table I have drawn here. So oxygen is in 16th, below that is sulfur, nitrogen and below that is phosphorus. So this is how they are placed. Now in case they are talking about ionization enthalpy, we know across the period ionization enthalpy increases. So this should have been more than nitrogen. But if you remember the configurations, this nitrogen and phosphorus both are having P3. They have P3, NS2 NP3. Their configuration is NS2 NP3, half filled configuration. And this is 16th group. Their configuration is NS2 NP4. So that means this will be having more. nitrogen is more than oxygen and phosphorus is more than sulfur. So what is the order here? For the first ionization I am writing here, nitrogen is maximum, and moreover down the group it decreases. So this group will be less, phosphorus and sulfur will be less. Then you have is oxygen. After that, out of phosphorus and sulfur, phosphorus is more and the least would be sulfur. This is about ionization enthalpy. Okay, suppose we are asked to arrange them in the order of the electron gain enthalpy. Again, for electron gain enthalpy, what we have is that smaller the size, more is the electron gain enthalpy. But again, there is an issue. If you see, for electron gain enthalpy, you have 3 exceptional cases. That is nitrogen phosphorus, you will have phosphorus more. Oxygen sulfur, you have sulfur more. Electron gain enthalpy I am talking about. Same is the next group, fluorine, chlorine. Chlorine has more. Only these 3 exceptional cases are there in the periodic table. So what you have is, these lower ones have more electron gain enthalpy than the upper one, their respective upper members, because of less repulsion. Okay, because the size is small, there will be more interelectronic repulsion. So if we are writing the order, it will be for electron gain enthalpy. Sulfur would be maximum, and then comes oxygen. After that is phosphorus, and the least will be this one, nitrogen. This is the order. This is more than O, this is more than N. Okay, what is the reason for it? The reason is, if they are smaller in size, there is more there is interelectronic repulsion. Okay, then in case they are asking you non-metallic nature, for this you'll have to see the size. Smaller the size, more the electron, more the non-metallic nature. So largest size is phosphorus. It will be the least. After phosphorus, the next largest is this one, sulfur. So then it will be sulfur. After that is nitrogen, and the maximum would be oxygen. This is the order for non-metallic nature. Okay, right. Then you have is lithium, beryllium, boron, carbon. If you are asked to arrange them in the increasing order of their ionization enthalpy, first thing is they all belong to the same period, second period. So across the period, ionization enthalpy should be increasing. So this should have been maximum. But what you have here is, this is comparatively more, beryllium, because it is having the configuration S2. This is having S2P1. This is having S2P2. Okay, so you will have like this, lithium, then beryllium is more, right? So it will be beryllium is more. Then here in between you will have boron. This will exchange the position, and the carbon will be more than this. Okay, so this will be the order. Moving on to the next question. Boron, carbon, silicon, aluminium. You are asked to write the highest in each case. Highest or largest, you can say. Highest ionization enthalpy, largest size, highest electron gain enthalpy. Okay, so first let us check, are they in the same group or period? No, they are not. It's like this, their positions. If we check, boron, below boron is aluminium, then after this is carbon, and below this is silicon. So one thing is, we know that with the increase in the size, the ionization enthalpy decreases. So ionization enthalpy decreases means definitely they are asking highest, means these are not. Either it can be boron or carbon. Carbon is smaller in size than this, because across the period size decreases. So the highest ionization enthalpy will be for carbon. Then for size, definitely for size, first two cannot be the answers, either aluminium or silicon. Across the period size decreases, so aluminium is comparatively larger in size, so aluminium. Next we come to electron gain enthalpy. Electron gain enthalpy means they should be readily increasing, adding the electron, taking the electron and giving out energy. So again the lower ones cannot be either boron or carbon. Smaller in size will be able to accept the electron readily. So here again carbon, which is able to gain electron readily. Okay. Then some oxides are given. These are all group 1 oxides, and you are asked to arrange them in the increasing order of the basic nature. Basic nature means more metallic. More metallic means the lower one. Down the group, metallic nature increases. So the basic nature of the oxide also will increase. So lithium oxide is least. Then you have is sodium oxide. Thereafter you have potassium oxide. Then you have rubidium oxide. And finally you will have cesium oxide. Okay. Francium we do not consider because it's radioactive. Okay. So moreover, interestingly, you'll find lithium forms, comparatively covalent compounds also, because lithium is abnormal. Lithium is not showing the properties of its own group members because it is having a diagonal relationship with magnesium. Some properties will be like this. Okay, so lithium is comparatively more covalent halides it forms. So properties are different. Next, you are having some members. These are again group 13 members. So all of the same group, acidic nature they are asking. Moreover, this is a part of P block. Basic nature increases down the group, but the acidic nature decreases. Acidic nature decreases means the least acidic will be thallium oxide, and then this you will learn later. I have written Tl2O, and in all these I have written 2O3, 2O3, 2O3. Because the last one, as of now, you can just see this shows inert pair effect. Inert pair effect. It's not able to exhibit the higher oxidation state of 3. It can show only 1. So it is the oxide. Then you have is indium. Then the next one is gallium oxide. Ga2O3, thereafter you are going to place Al, aluminium oxide, and then you have is boron. This is in fact amphoteric. This is most acidic. Okay. In case you are given same elements oxides, and then you are asked to arrange them in the increasing order of their acidic nature, you will have to check for their oxidation states. Keep one thing in mind. Higher the oxidation state, more is the acidic nature. Acidic nature will be more. More the oxidation state, more is the acidic nature. If you check the oxidation states of these elements, what you find is this is N2O. N2O. Nitrogen here is 1. Here nitrogen is 2. It's 3, 4 and 5. So I think it's very clear now. Higher the oxidation state, more is the acidic nature. So you are going to place, this is actually in order only. N2O, then you have NO and N2O3, then you have NO2 and N2O. This is the increasing order. Okay, moving on to the next question. Suppose you are having this HF, HCl, HBr, HI. Arrange them in the increasing order of their acidic nature. Normally you think HCl, because you have seen in the lab it is stronger acid. No. You will have to check for the bond length. You will have to check the bond length. Iodine is largest in size. Among all the halogens, it is largest in size. So the bond length will be maximum in this case. If the other element is H, H is common for all. So HI is largest. Then you have this. So obviously the one that is able to liberate H plus readily is a stronger acid. So you will have HF the least. Then you have HCl. Then you have is HBr. And the strongest is HI. The strongest acid. Okay. Now you have the next one is first ionization enthalpy. First ionization enthalpy for these elements. Check, are they in the same period? Yes, they are in the same period. Same period. Across the period ionization enthalpy increases, but at the same time please check group 2 and group 15, because group 2 members have NS2 configuration and group 15 have NS2 NP3 half filled configuration. So they will have comparatively more than the next member. So it is across the period it should be increasing. So this is of course the least, and then it should be Mg and then Al. Now this is slightly different. You will have here Mg, it is greater than aluminium, and then you will have is silicon. In case you are having this option as Al and then you have Mg and then Si, even this is fine, because overall Mg is greater than aluminium, because this is belonging, Mg is belonging to group 2, which is having S2 configuration, which is stable. Okay. Okay, the next question says fluorine, chlorine, bromine, iodine. These are all halogens given, and you are asked to arrange them in the increasing order of these properties. Oxidizing power. Oxidizing power means they should be able to undergo reduction readily. If you check the positions, they are fluorine, chlorine, bromine and iodine. So down the group their ability to gain electron decreases. So according to that it should be this, right? But you will have to see the electron gain enthalpy also. Electron gain enthalpy of fluorine is lesser than chlorine. Chlorine is the element which is having most negative electron gain enthalpy. But there are various factors which you will have to consider, keeping in mind the electron gain enthalpy, for which chlorine is greater than fluorine. Then you will also consider the bond dissociation enthalpy. Bond dissociation enthalpy out of these, fluorine is lesser than chlorine, right? And then if you are talking about hydration enthalpy is also greater for fluorine. Okay, so keeping in mind all these factors, you will have iodine the least, then you have is bromine, thereafter you have is chlorine, and the most oxidizing is fluorine, F2. Then the bond dissociation enthalpy, fluorine, chlorine, bromine. Down the group size increases. Size increases means the bond length is increasing. Bond length increases means the bond dissociation enthalpy should be decreasing. It is decreasing. So that means this is least? No. Only fluorine comes from here in between. The least is iodine. The next comes is fluorine. The next one is it is bromine, and maximum is chlorine. This is the order. Iodine is fine, but what about fluorine being smaller in size? It is having very less bond dissociation enthalpy. The answer to this is fluorine. It is very small in size, due to which these three non-bonding electron pairs on each fluorine atom are also close by. So due to which there is more inter-electronic repulsion. Due to inter-electronic repulsion, even fluorine is having very less bond dissociation enthalpy, and that is the reason why we called fluorine as a super halogen. It's a super halogen. It is a very good oxidizing agent, having least bond dissociation enthalpy and maximum hydration enthalpy. Moving on to the next question, which says for sodium, magnesium, silicon, these are the ionization enthalpies given. First ionization enthalpy is given, and looking at these, they are expecting you to answer for aluminium should have this or this ionization enthalpy. First, let us see their positions. It's like sodium, then you have is magnesium, then you have aluminium, and then silicon. They belong to the same period. Same period, across the period ionization enthalpy should be increasing. But if you remember, this we wrote earlier, this is having this is more. Okay, magnesium is more than aluminium. So since magnesium is this, aluminium cannot be more than magnesium. They are asking you to calculate for this. I mean, not calculate exactly, but just judge what will be the value. So it cannot be more than that. So answer is this. So for aluminium, the ionization enthalpy is 575 kilojoules per mole. I hope you followed it. The variation is like this. Magnesium should be greater because its configuration is S2. So it should be more than aluminium. So normally what children do is they think across the period size is decreasing. So it should be increasing in this order, means they mark it as 760. No, it's not 760, it is 575 because magnesium is given and aluminium is lesser than magnesium. Okay, Suppose you have a question like this, wherein the electronic configurations are given and electron affinity values are given. Electron affinity means electron gain enthalpy values are given. Okay, in whatever units they are given here, and you are asked to judge which value corresponds to which, out of it you have to match in a way. So what you'll have to see is, across the period the size decreases, so electron gain enthalpy is increasing. Do they belong to the same? No, they do not belong. One is not in the same. That is, this is the third period, remaining are all second period elements. So this should be the least. This should be least negative, in fact. Least negative, because down the group size increases, electron gain enthalpy should be decreasing. So for this it should be this value. And suppose you are asked, seeing the next one, this is noble gas configuration. Noble gas configuration, they will not accept the electron readily, so they will be forced to gain electrons. So their electron gain enthalpies are positive. So it will be something like this. Then you will have to check for these two remaining. This is a halogen. It's a halogen. Halogens have the highest electron gain enthalpy. So most negative you'll have to see. This is most negative, and then you are left over with only one. So you will be able to judge this. Okay. I hope you have followed all these arrange the following questions. Please practice it so that you get more confidence. Thank you.